Hey guys, this is Morteza and I'm an assistant professor at the Electrical and Computer Engineering Department at the University of Utah. Welcome to Microelectronics Design Automation Lab channel. The next section that we have here, it's usually background and related work, and uh, usually it's structured as sometimes we have some subsection. It's called for problem formulation. That like we talk about like what is kind of what is the way for formulating our problem. This is optional. Some of the papers they don't have that. Sometimes we can have that, if especially if we have enough space. But more important, it is the related work. Okay, so we should cite the previous similar work here. For citation, we can sometimes, if there are like some important like recent state of the art work, it's good to individually cite them. For instance, saying that okay, the previous work. The state of the art previous work basically was we're doing that, this was their approach, and this is their problem. Okay. But if they are like older works or the works that we are not, we don't want to that much emphasize on that, but we want to tell the reviewers, okay, that see, I have done my homework, I have read, I have gone through all of the previous work, and I know what is their problems. Okay. For that, we can say, okay, like work, like work 2, 3, 4, 5, 6, basically they were using, for instance, like a neural network approach, but they were supervised. So all of them, they were like facing large training data. That's meaning of that. And so it's very good basically that we kind of group and compare the similar work together. So because for instance, like for the circuit design automation, for analog circuit design automation, some of the approaches that we're using, for instance, like simple DNN, some of them were using, for instance, graph neural network, some were using Bayesian optimization. So it's very good that like in each paragraph we say that okay, these works they have been using, for instance, Bayesian optimization, we group them, and we kind of compare them with each other and with our work. Okay, this is very important, that I completely think that okay, you wanna teach one person like your the previous work, so it's better to like group them, organize them, to give it a good, like very clear again look, instead of saying okay, that first line we talk about Bayesian optimization, then second line neural network, then third again we go back to Bayesian optimization. That won't be that much organized. The last thing, basically, this is very, very important. Say that how our approach is better than others. Okay. So basically, for each of these blocks or each of these um, previous work, we should say, okay, that for instance, like again, like they were using supervised learning. That is their problem, and our approach, because it's not supervised learning, we have a better, I don't know, like less training data or whatever. Okay, it's better. It's very, very important that we say, okay, how our approach is better than the other approaches. Okay, to see an example, here is the background section. As we can see here, we have like a subsection, a small subsection of that problem formulation. Then, uh, because in this work we had two kind of aspects, we divide them, divide the previous work basically to two parts. Some of them that we're doing for reducing the database size. Here we have named them. And this is basically what I meant by like blocking them. And this is like an example of individually cited. Because in this work, we kind of have compared our work a lot with, we compared Angel with this work. So we have named uh, and cite basically and analyze this individually. Then there were other works that we categorize them as circuit design framework. Again, you can see here we have these groups, blocks of work that were similar, then another, and so on and so forth. Okay, here because like we had again like 14 pages, we could like talk a lot more about that. We could compare a lot of works basically. Sometimes that doesn't happen. So in that regard, it's very important again to group the work together and like not individually compare with the previous work, unless that is something that is very specific, that we want to say how our work is better than they. Okay, so let's move on. This is kind of the methodology part. uh, uh, that we kind of talk about exactly more technical that how we have implemented our framework. So so usually basically what I do, I have one subsection as an overview. Again, this is optional. It shouldn't be always like that. But again, this is like one good structure for that. That in this overview, it can be one to n paragraphs kind of, that I talk about the flow chart of our work. Okay. I say that, okay, for instance, this is my flow chart. This is like kind of our my platform. This is how different blocks are working together. And I always add a flow chart image, flow chart figure, which is very important. And just like talk about that how different blocks are working together. Then in the subsequent subsections, I talk about each of these blocks. Okay. So in overview, I say, okay, here, this is one overall topology decider that give the specification to the subcircuit topology selector, then it gives it to sizer, so on and so forth. This is how the different blocks are connected. And in uh, the next subsection, I talk about how overall topology decider works. In the next subsection, I talk about how the subcircuit topology selector works, and so on and so forth. Okay. So again, let's see the example of Angel. Here we say, okay, this is an overview. We talk about this flow chart. Then we talk about each of those blocks basically. Okay, this is the overall topology decider module. Then we have the subcircuit topology selector module, and then like the other part, the circuit sizing and so on and so forth. All right. Uh, Kind of the last important part of the um, our paper is the evaluation section. Very, very important. It is very important basically that um, we give enough figures and tables. Okay, as we talked at the beginning, reviewers won't have that much time to go over, like read exactly like each of basically line by line basically for our work. So what they do, they scroll the paper and look at the figures and tables. Okay, so we should have, instead of like talking that much about our result in like by text, we should try to summarize them as table and as figures. Usually, basically, I start with like one paragraph, one to couple of paragraphs about like my evaluation system kind of in general. That, for instance, I saying that, okay, I use TensorFlow, I use that GPU, that CPU, something like that, some kind of giving like an overview basically of what's going on in this evaluation. It's very, very important. This is super important to add a comparison table. Okay. Again, if your work is great, okay, and you just say that my accuracy is 90%, even though that in the related workstation you have mentioned, okay, the previous work they have like 70% accuracy, no one, it's very, very hard to uh, it's very, very hard to believe that the reviewers will gonna like exactly read that section. So add a comparison table. This is what the reviewers are looking for. Okay, like reviewers, they have like a certain structure in their mind, and they want to see that structure. One of them is the comparison table. They want to see a comparison table that you have compared your work with the state-of-the-art approaches. Okay, this is very important. Add as many as tables and figures as possible. Try to report your data, your result basically in figures and table format more than like writing. For sure, we should have some text that we kind of give more explanation that, okay, that what's going on in this image and what's going on in this table, but reporting them in tables and figures are more important. Again, it's very important to report our result in absolute and more important comparison times format. And here basically is the results section. This is the first paragraph that I talk about like this environment that I use ReLU, for instance. This was like kind of the learning rate, so on and so forth. So just give it some like, overview. Then we talk about like each of those sections. Again, here we can see that we have these tables, okay? Instead of reporting these numbers like in text, I use tables for that. We can see we have different tables for some of them. it shouldn't be all of them, shouldn't be like the comparison table. This is kind of a result summary, okay? Again, I use table for that. But I have this comparison table as well here that I compared Angel with the state-of-the-art approach. Okay. And then I talk about, okay, that how much, like for instance, like Angel is, I don't know, like 1,000 times better than the previous work. Okay. Again, I added figures basically as much as possible. Again, this is another comparison table here with the state-of-the-art approach. It is very, very good also to give one complete example of how your flow, your tool works. Okay, so here, as we saw, we have this Angel had different sections and everything, but I gave one complete example that, okay, that if you give these specifications to Angel, I should find that, where was it? But yeah, if you give those specifications to Angel, this would be kind of the final result. Okay, so it gives it like it would makes it completely clear that okay, what is input and what is output. Okay, so basically we give that the input sections here, and we have basically have this like kind of as a final out. All right, the last section is conclusion, which is the spin off of our abstract. It takes usually like 15 minutes to write that down. We don't talk about the difference is that we don't talk about like the importance of the problem and usually issues with the current approaches that much. We just say, okay, that a summary of our approach and kind of our results section. Here is the Angel's conclusion. Say that, okay, we use basically neural network. This is that much better. And like again, like another result, and that would be it.